Now I'd like to welcome our next speaker, Lisa Argyle. Lisa is a professor currently at Brigham Young University, but moving this fall to be an associate professor at Purdue University. Lisa's a rising star at the intersection of computational social science and political behavior, political psychology, very much near and dear to my interests. So very excited to hear also what she has to say. In recent years, she's been focusing particularly around LLMs and ChatGPT and its potential to advance social science research. We're very thematically clustered here this afternoon. And her work has been published everywhere from PNAS, where she has a forthcoming paper looking at the use of LLMs to test theories of political persuasion, which is very exciting, and as well as papers in the APSR and sociological methods and research and elsewhere. So I'm really tremendously pleased to welcome Lisa. Thank you. Welcome.
There we go. Great. Thank you. I am so pleased to be here and so grateful for the invitation. I'm going to start today with an apology and some acknowledgments. And the apology is brief, and it goes like this. I have a terrible sense of humor, and I cannot resist a good pun. Hence the title of this paper. That comes with some acknowledgments because the initial user of the title of this paper was my daughter, who happens to be here today, as a title for her middle school science fair project. So I appreciate her graciousness in letting us adopt that title into this work. And also, she was also the design consultant on these slides for today, so she had to make sure I did those right. Some other acknowledgments as I get into this work for today is the rest of the team that works on this project. So I'm here presenting some ideas that we have collaboratively been talking about for many years. The folks on the top row are political psychologists. The folks on the bottom row are computer scientists. So this is a truly interdisciplinary collaborative team. And together we've done a lot of work with language models. We've been working with them since 2020 and have produced a few papers along the way, a couple of them, where we're trying to, I think, as in the Brandon's typology, innovate, trying to push the boundaries of what's possible in social science research using large language models. But as we do that, we see a lot of research, we do a lot of research, and we spend a lot of time talking about what this tool is and how it can help us, and some of the roadblocks that we face, some of the pitfalls, some of the weaknesses of the tool. So that's a lot of what I'm going to be talking about today. I'm actually going to be picking up right where Brandon left off and taking the high-level view of what do large language models look like in social science research, and how can we sort of productively use them as a tool in the social sciences. And this is all coming from a perspectives paper that will be coming out in Nature Computational Science in a couple of weeks. So we just sent page proofs back. You'll see it soon. But that's where this is coming from. So some of our high-level thoughts about what does this mean for this pursuit of science. So we'll start out talking about some of those high-level big ideas about science and language models and how they interact with each other. But then also looking at, as we use language models, sometimes they do the things that we want, and sometimes they don't. So what do we learn from when language models fail us or fail to do the tasks that we want? And what do we learn when they succeed, or how can we build knowledge collectively as a scholarly community when they succeed? And end with some recommendations, hopefully a few practical things, and hopefully some ways of thinking about these tools in our work, whether you've started to use them or not. We're sort of hoping this is applicable across many disciplines and in a big way. So thinking about LLMs in the scientific process, one, I suppose, caveat here. One, I will acknowledge the limitation that I'm very much coming at this from a positivist scientific perspective. So we're thinking about the scientific process, and we're thinking about inference as an end goal of that scientific process. And I think you could probably find on the program for this conference, and if not, certainly in the broader scientific community, applications of large language models that are happening in every stage of your typical scientific research process. People are using them to summarize literature, to come up with research questions, as part of the data collection process, as part of the analysis process, as part of the writing and reporting process. We're using it in every aspect of the scientific process, and so we really need to be thinking about this in the big picture. And on our team, as we thought about what language models mean as a tool, we started to realize that some of what's going on here is language models, they are a machine learning model at their core. But what they're doing to science and society isn't like other machine learning models. And how we have to think about our interactions with them and their effects. We think, in terms of an analogy, we think maybe it's a little bit more like the internet than it is like a random forest, right? And in particular, we've thought about sort of several parallels. There can be many others. We can talk more about these, but just sort of like as a high-level overview to think about the scope and the range of what language models are doing. We have some of these kinds of we have some of these kinds of changes, right? Things that the internet changed for us, things that we think language models are also changing. How we are understanding and consuming research, how students learn. We're probably encountering that in our non-research hat of our positions. The process of writing, of thinking, of disseminating knowledge, how we approach information and our access to it. Our interpersonal, social, and professional communication, the way that we interact with each other is being shaped by language models. And also how we as social scientists interact with human subject data in the same way that the internet made, for example, archival records or administrative data far more accessible and easy to access. Language models are doing not quite the same thing. It's not giving us the data, but people are using it to do more like record linkage and matching. We're doing it for agent-based modeling, for simulations, to produce data, to produce network data, right? All of these kinds of things. And so it's changing the kind of data that we're using as well. But LLMs are really fickle, hence the title. Right? And by fickle, I mean that language models can do a lot of things, but just because it did it for me today or last week or in a previous paper doesn't necessarily mean it's going to do it for me tomorrow or for you and your related but not exactly the same research project. And also, they're moving really, really fast. So just because language models can't do something today, I'd make no bets about what they will be able to do tomorrow or next week or sometime next year. So they're fickle in that their capabilities are both coming and going quite rapidly as this technology changes and as we change our interactions with it. So part of that fickleness should give us some pause as a scientific tool. How do we use a tool that we're not totally sure what it's doing today and what it's going to do next week? How do we use it as a scientific community, given some of this instability and the rapid change in it? And our argument that we want to make here is that language models are good tools for social science if they help us make better inferences. So that lets us not put away, not sidestep, but sort of shift our focus a little bit from the question of stability and replicability into thinking about what kinds of scientific inferences are this use of a language model allowing us to make. So this is very much coming from a perspective where the goal of science is to make inferences. It's to build theories, it's to use theories and facts together to better explain things in the world. So not just the fact that's in front of us, but then what does this help us explain in a broader sense about the world? So not just the pile of rocks, the facts that we collect as we interact with language models, but the houses that we can build as a scientific community together. How do we give structure and form and meaning to the collection of facts that we get as we interact with language models? So in this sense, I'm thinking about the facts and the scientific pursuit as what the language model did. So given a particular settings, given a particular prompt, a language model produces a particular kind of response. We ask it some query, it gives us some answer. We ask it the same query again, maybe it gives us a slightly different answer. There's some randomness there. But in general, we're thinking about that fact is just sort of like, what did the language model do? how then do we make an inference out of that fact? Right? The language model gave me some response in reaction to a query. I asked it to code some text, and it gave me an answer. I asked it to produce some persuasive message. It gave me an answer. What kind of inferences can I draw based on that particular fact? And I'm going to start by saying, and we'll spend quite a bit of time on this as I keep going, that one of the core questions there is, in that fact, if the language model behaved in this particular way in response to the query that I gave it, or in response to the prompt that I gave it, does that performance constitute a success or a failure of the LLM to perform the task that we wanted? That's a really fundamental question that's actually really hard to answer, which is why we'll spend some time there. I think the other important thing to remember as we start into science using language models is to think about what our target of inference is. This is maybe a slightly different way of categorizing the science that's out there, but maybe not all that different than what Brandon just showed us, right? What are we trying to draw an inference about? And that can be a lot of different things. And for folks in the room coming from different kinds of disciplinary backgrounds, it probably is a lot of different things. It might be the LLMs themselves. Are we trying to understand LLMs and their behavior? Is that the inference we want to draw? Are we trying to understand human behavior? Is that the inference that we're trying to draw in this setting? Are we trying to understand actually the scientific process itself? The language models could be doing that. Are we trying to understand, are we trying to infer something about real world interactions or experiences? Are we trying to infer something about a theoretical concept? We could be doing all of these things in different scientific settings. And I think this is really important because the kind of inference that we want to draw, or what we're trying to draw inferences about, then really shapes how we think about the validation and their application and the methods and the tools and the way we approach using a particular language model. And so if we're trying to draw an inference about some theoretical concept, say we're trying to have a language model code for populism, and we're trying to draw some inference about that theoretical concept, then the way we're going to validate whether the language model is understanding that concept and interacting with it in the right way is going to be really different than if what we are trying to draw inferences about is, the behavior of countries or the behavior of people, and the language model is just an intermediary step along the way. All right. So let's think about success and failures of language models. We approach the language model with some task, and intentionally this is big and broad because we see lots and lots and lots and lots of different ways that language models can be used. And certainly one of our team's goals, and one of my goals in this presentation, is not to limit our thinking into the standards or the ways of practice that we should be using that are based on one particular approach to language models, if we're using them as text annotators, if we're using them as simulators, if we're using them as literature reviews, if we're using them in more qualitative ways, whatever approach it is we're using, we should be able to apply the kind of thinking and the kind of approach that I'm outlining here today. So I really want to be thinking broadly, but I'll try to give us some signposts along the way so that we have some examples. But that's a little explanation of why this is a bit big and broad. But we approach the language model with some kind of task, and we're going to start with failures. So we look at the language model output, and the language model maybe didn't do exactly what we want. That's our fact. That's the first stone that we have. We say the language model didn't do exactly what we wanted in this case. What inference can we draw on the basis of that fact? And a big answer to that question comes from understanding why the language model failed. So what inference we can draw changes depending on why the LLM actually didn't do the task that we were hoping it would do. So at the highest level, well, I guess maybe at the deepest level, at the most fundamental level, a language model can fail because no language model has the capacity to do this task. It might just be a task that language models themselves are not well suited for, something they're not trained to do, something they're not capable of. There are any number of tasks that language models do poorly, or any number of tasks that language models can't right now do. So it's possible that the language model fails just because language models can't do the job. But another reason that language models could fail is just because the particular LLM we're using at that moment can't do the job. But maybe another language model could. Or maybe a language model with different training could. So as we think about biases in language models, What changes if we change the training data of that model? What changes if we use a different language model? So another reason it can fail is just because the particular language model that we're using doesn't have the capacity for the task we're trying to ask it to do. Another possibility is actually the language model is totally capable of doing the task, but there are, in most of the language models that we all interact with, nearly all of them, some layer of alignment process, some layer of instruction tuning, some fine tuning, some kind of alignment process. Alignment is super helpful. We started working as a team with language models before, or with GPT-3 prior to actually any alignment being introduced in that model. It was very difficult to work with. It did not follow instructions. It was not a helpful chat assistant. We started wondering if we could use it for studies of racism and racist attitudes, because it would say all kinds of things if you asked it to and take any number of personas. So there are a lot of reasons why we like alignment and we want it to do that. There are some ways in which alignment helps it accomplish the tasks that we want it to do. There are many, many things that language models do better as they get more reasoning capabilities, as they become more aligned. They give us source material for their information. They're helpful and friendly chat assistants. They don't produce violent or threatening information. They don't produce private information, all those kinds of things that we want. But there are also settings in which the alignment can prevent it from doing a task that otherwise it probably has the capability of. But because the model is aligned in particular ways, maybe it doesn't produce a full range of attitudes that we're trying to simulate. Maybe it does. Sometimes alignment even works with tasks that are if there's something in the prompt that it's aligned not to respond to, it might refuse to do even a benign task. So if there's something, in the way that a prompt or an example is given, it might prevent it from doing a task fully accurately. Language models can also fail because we're just not very good at using them. And so here I said that is poor information extraction. This is a prompt engineering problem. It might be other kinds of settings or interactions that we have with the language model. Some of that might be the conceptualization of what the task that we want the language model to do. And so language models work really well if we know exactly what we want them to do. But if we're relying on the language model to fill in the theoretical and conceptual gaps that we have left for it, then it may not do that task very well. Better prompting can sometimes help. So why does all of this matter, right? Knowing why a language model failed to do a task that we're asking it to do can tell us a lot about the potential kinds of solutions or problems. But we don't want to sort of overinterpret a failure, meaning if actually it's just where we had a bad prompt, we don't want to say language models are completely incapable of doing this, right? So if a problem is down here at the lowest level, we don't want to say that it's actually a problem of that highest level, complete failure, catastrophic failure of language models to do this task in its entirety. On the other hand, if actually language models are not good at tasks and they're not the right tools, we don't want to spend hundreds of dollars, thousands of dollars, all of our time trying to prompt engineer, trying to fine tune, trying to, run this on multiple different models. Right, so there is a cost in terms of the time and actual expense to underinterpreting a language model's failure as well. So part of this is just for our own research practicality, and also as we try to build knowledge as a scientific community, being able to understand the different reasons why language models might fail at a task can help us better communicate as a scientific community about the potentials and outcomes of a language model. The big downside is that right now there's not some systematic test to determine why a language model failed to do a task. It's really tempting to just go ask the language model if it can do the task. I don't recommend you trust its answer. They're very helpful and they will always tell you that they can do things. Right, so we don't have any kind of systematic test to determine why did this fail. That means we have to be a little cautious about inference on the basis of failures of language models right now. What we can say is some kind of fact. The language model that I was using failed to do the task that I had in mind. But it is going to be a little hard to determine sort of what the root cause of that failure is along the way. So in the meantime, our recommendation is just really transparent documentation and public reporting of our failed attempts. I know it's hard to report our failures. But that's how we're going to build this kind of systematic knowledge that we need. We don't need it to be incumbent on every individual researcher to try every variation of the prompt on every possible language model before determining sort of what's possible and what's not. Instead, we can sort of build that knowledge in a scientific, scholarly community way, but only if we actually share that information as a scholarly community. So what about language model success? Sometimes language models do the task that we need, and they do it really well, and that's fantastic. We love that. But it's also kind of hard to figure out when that's the case. So trying to answer the question of did the language model succeed is actually pretty complicated. And one of the reasons for that is because what success looks like is often also pretty complicated. As I've already said, this can really push us to be better at conceptualizing what it is that we care about and what it is that we're talking about. Because sometimes we're asking it to do tasks that are really multifaceted, and there's not one clear indicator of did it do the task in exactly the right way. Another problem we have is that even really similar tasks might have different markers of success. Right? So let me give you an example of this one. Some of my work has been in the realm of silicon sampling, meaning using language models to produce sort of replicas of human survey data. Lots of other folks have been working in this space as well, including some folks in the room. And there's a variety of takes about how successful that is. Language models have a variety of different performances on silicon sampling kinds of tasks, on human data replication tasks. Some of that, by my interpretation, is because we're all using different standards of what success looks like in that case. Are we using some kind of aggregate value or proportion? Are we using subgroups? Are we using mean values for subgroups is the most important thing? Are we using variance in the outcome? Are we using precise prediction of a particular case? Or in our most recent paper, we're actually just using, like, did the language model refuse to do the task or not as one of the core metrics of success, right? So we have all of these different kinds of success indicators, and which indicator we're using really changes how we interpret whether the language model is succeeding or failing at the task. That's hard. And this is the same thing that's happening in a variety of other areas where language models are being used, because it's really hard to define what success is, we end up using a lot of different indicators of success, and those lead us to different conclusions. And so that it can be hard to interpret. How do we take that pile of rocks and turn it into a house and create meaning and theory and inference from that? Another problem we have is that, at least for right now, and I remain optimistic about the future, but at least for right now, success in a language model seems to be non-transitive. Right? Just because somebody did a coding task on one topic doesn't mean the language model, a different language model especially, can do a coding task on another topic, even if they seem pretty related. Right? Like, if somebody told me that language models did a really good job of coding what democracy looks like, I don't know that I would then necessarily believe that they can do a really good job coding what authoritarianism looks like, right? We sort of have to, in every study, go back to this validation of what it means, and we can't just rely. This is part of where it's a little different than other kinds of machine learning tools, where we might have methodologists who give us a formal proof and say this is how the tool works, and it will always work, and then we can just cite that and move on. And language models, at least right now, don't have that kind of same transitive success. We have to go back and rethink what does it look like and what behavior should I expect in every case. The final consideration about whether the language model succeeds is that success is model dependent. And so language models perform differently. They change over time. Language models in different families perform over time differently. Language models with different kinds of alignment features perform differently. And so it's really hard to make inferences about what language models in general can do. Much more reasonable to make inferences about what a particular language model is capable of. So the recommendation that we have in this case is to validate, essentially. And at least for the time being, we need to be thinking about what the validation of any language model looks like in the particular use case and application that we're doing for it. And we need to be going back to validation in every study. And in particular, we're going to be a little bit more specific about what that might look like in terms of a normal social science research workflow, open science research workflow. And so that means asking this question. Prior to using the language model, or as you get into the study design phase, what would success look like for the particular model on the particular task that you're maybe not the particular model, but for the particular task that you're asking the language model to do, and does the language model meet that standard? How do you know? Right? What does success look like, and can the language model meet that standard in a demonstrable way? We think we could do this in sort of like two variations on a workflow using pre-registration. So one variation of this is you start out by defining your benchmarks, saying, here's what success in the language model should look like. And I mean benchmarks here to be very broad. It might look like using some of the computational science benchmarks that are out there. There are lots of benchmarks we use to evaluate performance of language models. If those align really well conceptually with the kind of thing that you specifically are doing, using some of those benchmarks might work. It might be a lot more qualitative than that. So benchmarks can be a quantitative thing. It can look a lot like what Brandon was describing for coding tests. It might look like having focus groups. Look at, especially if you're doing some kind of interaction with a language model, right? That there may not be benchmarks for, did that feel like a natural conversation? But what there might be is a focus group or a pilot study. It might look like researchers doing a lot of expert evaluation of a set of outputs from the language model. So I mean benchmarks here to be broad and to encompass a lot of different things that we can do in our workflow. But setting up those benchmarks ahead of time, then pre-testing your language model, saying, here's what I want the language model to do. Then we're working on prompt engineering. We're testing out different language models. We're figuring out what's the right combination of settings and models and prompts that actually gets the language model to do the thing that I said I needed it to do when we set out. And then pre-registering. So in this case, the pre-registration would probably include a lot of that information. It says, here's what the benchmarks are. Here's the evidence that the language model met those benchmarks. And so therefore, in this study, when we run it, we're going to use this model with these particular kinds of settings and this particular prompt. And all of that information could go into the pre-registration, at which point you can run the study. Probably in the follow-up reporting, there should be some kind of validation that the language model worked in the study the way that we expected it to based on the pre-registration. But that's one model of how this workflow could look like to incorporate language models in a transparent way, in an open science way that still lets us sort of validate that they're doing what we want in a variety of tasks. A second workflow could look like this. The first workflow is good for settings where we have a discrete use of the language model, probably in a particular time frame. And so if we're looking for something that's a little bit more exploratory, or that we're looking to do an analysis of data downstream and we don't have that data yet because we haven't collected it, right? We might need a little bit more flexibility in what we do in the pre-registration. We might not be ready to sort of put everything up front in the pre-registration. So in that case, we propose a second workflow that says we can define those benchmarks ahead of time. We can say, here's how we're going to decide if the language model is doing what we want. We can pre-register that set of benchmarks. And then, whether we're using the language model before or after data collection, we can sort of run the study and work with the language models to do all of that prompting, all of that defining which model, prompts, model specifications, model choice at that point. And then in the follow-up, we can provide the evidence that the benchmarks have been met by the language model. So this is our proposal of a couple of ways that we think you can use open science practices to still provide a lot of transparency, even as language models are being used in such a huge variety of ways, and even as there's a lot of churn and turnover in the capabilities of language models over time. So we'll summarize some of those recommendations for you as the last point here. Prior to the study, having a really clearly defined target of inference. I think that really helps clarify, and for our team, that has really helped clarify what is it that we're trying to actually make an inference about, and how is the language model supporting that inference? And that says a lot about the kinds of validation that we need for the language model in a particular case. Prior to running the study, we need to have some standards of success. What does it look like for a language model to succeed at this task? Often that requires a lot of conceptual thinking, and that it's natural to want to offload to the language model or to not think about the fuzzy, hard cases, but really thinking about what does it look like to know that language model has succeeded in a way that I can transparently communicate to my reviewers, to editors, to the research community. Pre-registering those benchmarks. And then in the study report, following it up, making sure that what we're trying to draw inferences about is clear. Is the goal of our inference about the capacity of language models themselves? Is it about human behavior? Is it about some other aspect of the scientific process? Providing that benchmarking evidence. Did the language model do what we asked it to do? And then reporting detailed LLM information. I've talked a little bit less about this. Reporting detailed LLM information in every use. That should include probably the dates of runs of using the language model, because they change often. It should include the specific model used. It should include the prompt. As much of that as possible, we think should go in the main text of the paper. Just like, if you were running a survey experiment, you would expect the text of the experimental treatments and the survey instrument ideally in the main paper, but sometimes it gets a little lengthy, and so that can go in an appendix along the way. And also reporting those other exploratory efforts. We think that's good for building the scientific knowledge, the things that we tried and didn't work. We also hope that makes it easier when dealing with reviewers, or maybe as some of you in the room are reviewers, you can sort of see they worked on this, they did a process, and we can head off some of those. But what if you tried this other model, or what if you tried those other prompt kind of questions in the review process, if we're really transparent about what the standards look like and how we worked to achieve them in the manuscripts up front. All right, that is what I have for you today. Thank you. I am happy to answer some questions.
That was great. Thank you. That was amazing. Questions? I see right in the first row, Marcus.
Yes, thank you very much. Nice talk. Markus Strohmeier, University of Mannheim. So there is this discussion in computer science between fine-tuning and prompting. Some say fine-tuning is dead, but 2 weeks ago we've just had the presentation of this LLM of human cognition in Nature that is a fine-tuned model representing human behavior. You're presenting lots of work on prompting, which is fickle, as we have learned, and prompting maybe is more of an art than an instrument right now. And having sort of 40% PhD students here in this room, what advice would you give sort of PhD students working on LLMs and in silico modeling, perhaps? Especially given that the prompting part, which seems to be quite central for the use of LLMs as a scientific instrument, is we could produce a generation of students that have prompted their way to a PhD. How would we evaluate sort of this next generation of PhD theses that are coming out of it? And do we expect that in the long term we will end up with fine-tuned models that have very specific behaviors? Or do we more focus on sort of the front-end engineering of the characteristics and qualities of these models? That would be sort of my direction of the question.
There are like 5 questions embedded in there. I'll try to answer a couple of them. One of them, I think, what I've tried to present here should be flexible enough to account for both prompting and fine-tuning, right? So one reason we might not be able to access the information we want from a language model, or the particular language model we're using isn't working, fine-tuning might be a solution to that. That's fine. Fine-tuning is getting less costly and demanding fewer computational resources, but maybe not. It's certainly more costly than prompting. So prompting, I think, is a first solution, particularly for PhD students, is a good route, but I think there's growing evidence that there are some kind of tasks where an appropriately fine-tuned model with the right kind of data probably will outperform prompt engineering. I think that's the researcher's discretion, and I think that fits entirely within the framework that we're trying to propose here, is to say, there are lots of reasons language models can fail, and there are ways we can get around that. And both prompting and fine-tuning I see as possible solutions to that. The other related question in there is how do we deal with this in pedagogy? How do we deal with this in student learning? What does it mean to learn and know things and to be good at skills when we're using language models so much? And I wish I had a good answer for that. And I don't. I think it's going to take a lot of time to see how that develops. It's going to take a lot of our collective effort to think about what are the essential skills of being a social scientist? What are the capacities that we have as humans that language models are still not good at mimicking? And so how do we focus students and teach them those core capacities? It's probably going to take some flexibility and creativity on our end. It's going to take some effort to get students to pay attention to those core capacities as well.
All right, terrific. Question, Laura.
Hi, thanks. So excellent. And then I'm wondering, in the scientific inference process, when you're using, so this is not to study how LLMs are impacting the world. If people are using ChatGPT, we need to understand how ChatGPT is influencing the world. But for scientific inference, should we be avoiding these closed source models, like vehemently avoiding them? And there's some other people in this room who have made that argument because even if you put a date on it, nobody can go back to that date and replicate what you did with GPT. We don't know the weights. We don't know what the engineers are doing. If we want to understand how the LLMs work themselves, we are just making sometimes wild guesses when it's closed weight models and we don't know which layer is affecting what. And so would you, again, 40% PhD students in the room, should we be avoiding closed source models in those scenarios, and how strongly? Because those models are powerful, but they're also bad for science in some ways.
Yeah. This is part of why I think we have a focus on inference. And I'm not going to take a strong position on open or closed source model. My general disposition is you should use the model that is the right model for the task that you're doing. And there are some tasks where the closed source models are going to be better at those tasks. And there are some tasks where the ability to exactly replicate something down the line is going to be the highest priority for the inferences that you're trying to draw, in which case you should be using the closed source models. I don't think it's a clear answer in that trade-off. So I'm sort of like, that's where I stand on that part of it. We should be thinking about transparency. We should be thinking about replication. I also don't know that, right, like everybody storing 1 million specific time-stamped versions of language models on servers all over the country is going to necessarily be better for replication, if in reality we never go back and use them. And so we should probably be thinking about community building and how can we get open source models that many people can use in particular ways, instead of iterating, well, both the computational costs, the environmental costs of just having 1 million versions of all of the models, because they're then open source and time-stamped and closed. I think we should be thinking about community solutions to that kind of problem. But I think there are some instances, and I think you pointed out one of them in particular, that like if we're studying how people interact with language models, we should be using the language models that they're interacting with. And so I think it really depends on the kind of inference that we want to make and what properties of a model are best aligned to help us make that particular inference.
Okay, great. More questions? Let's see. Is there a hand? It's a little. Oh, sorry. You were in a dark corner, so.
Yeah, thanks for this presentation. And as one of the 40% of PhD students here, you were talking about kind of like that you have to, for each task, define like what does success look for you, and then develop a benchmark on this. And I'm a little bit curious as to whether you could share some more insight on this, because I would think that like success in a scientific way has like some certain epistemological properties where we can kind of like say, okay, this should be some form of like scientific success, right? And so that we can develop benchmarks, not like into the wild, so to speak, so that we then have like a replicability crisis based on like everybody does their own benchmark, and instead have some form of standardization. And my question would be like, do you have some pointers where we can start kind of like thinking about, okay, what what are various instances of what a success in this rig could mean, and how to like define benchmarks for that then are comparable also to other benchmarks for other people in those things, and how variant this is, or like how broad or narrow we should be thinking about that.
Good. For me, the answer to this depends a lot. There's a lot of variation in what success looks like, and there's a lot of variation in the different sort of like sub-communities of how people are using language models. And so I think language models as text annotation is one of the most well-developed. And so there are, because we're coming from a tradition in machine learning where we already have really good benchmark standards and really good practices for understanding do we have good text annotation here? I think language models have been able to fit nicely into that workflow. There are good standards and a lot of community dialogue about like what would it look like for a language model to be successful at a text annotation task. In that case, I think those metrics and those standards will come out of that research community, and there will be sort of comparable things. On sort of the other end of the spectrum, right? So my most recent PNAS paper, we use language models to try to persuade people in one-on-one conversations with them. And we have language models take a variety of different persuasive approaches in that conversation. And so does a language model do a good job at trying to persuade someone? Does a language model do a good job? One of those treatments is like a cognitive interviewing, motivational interviewing, treatment. And like there's not a metric that says like, was this a good free-flowing conversation that has the principles of motivational interviewing, beyond us as researchers spending a lot of time with it and doing a lot of qualitative work there. So I think it's going to vary. And I think there is some tension between we want something that we can just point to and say, this is the standard of success that I have to meet in order to do it. But as social scientists, we're often dealing with concepts that are very nuanced, that we think a lot about and we should be very careful with. And so there's a bit of tension there. How much can we use the benchmarks that are being developed and the ones that do exist and the ones that are common, versus how much do I really need a benchmark that captures my precise meaning of the concept in this particular study and case? And I think that tension's going to keep playing out. I don't know that there's an easy resolution to it, but I think it's something to be aware of, right? Like just picking it up because somebody else used it doesn't necessarily mean that it means the same thing in your study that you're trying to claim it does. So some of this is a measurement validity or concepts, and we should really be good analytical thinkers. And I think critical consumers of benchmarks that already exist, recognizing that replication is helpful for scholarly communication.
All right. Shall we take one last question? Or do you have a question, or are you just handing out the? Oh, I didn't know you were taking the mic to ask a question, or you're. In any case, do we have one final question? Because I know then we'll have to shift to dinner phase. Or we will call it. I think we will shift to that phase now, and I want to say thank you for an incredible presentation.
Yep.